Okay, in last lecture we have started the next point, that is dimensional analysis. Okay, so what is meant by dimensional analysis? Dimensional analysis is nothing but it is a mathematical technique. What is meant by dimensional analysis? It is a mathematical technique which makes use of the study of the dimensions for solving several engineering problems. Okay, so this is nothing but dimensional analysis. What is the use of dimensional analysis? To test the dimensionally homogeneity of any equation of fluid motion, then to derive rational formula for a flow phenomenon. Okay, to derive equations. These are the use of the dimensional analysis. Then what is meant by fundamental quantities and derived quantity? The quantity which does not depend upon the other quantity. The quantity which does not depend upon other quantity, that is nothing but fundamental quantity. And what is meant by secondary quantity or derived quantity? The quantity which are expressed in the terms of fundamental quantity, that is nothing but derived quantity. Okay, fundamental quantity, what are the examples for the fundamental quantity? That is mass, length, time, temperature, etc. And what about the derived quantities? That is velocity, area. These quantities are depends upon the primary quantities. Okay, so therefore we said that this is nothing but derived quantities. Okay, then we have discussed about the what is meant by dimensional homogeneity. The expression is said to be dimensional homogeneous when the dimension of left hand side is equal to the dimension of the right hand side. Okay, ज्यावेळेला दोन्ही साइडचे डायमेन्शन सेम असणार आहे त्यावेळेला आपण काय म्हणणार आहे, ती दोन्ही इक्वेशन डायमेन्शनली होमोजिनियस आहेत. ओके, then we have, after that we have make one chart and we have written the dimensions for that particular quantity. Okay, so there are fundamental quantities are there, geometric quantities are there, kinematic quantities are there, dynamic quantities are there, thermodynamic quantities are there. We have written the symbol of the each quantity, we have written the unit of each quantity, and from that unit we have written the dimension of the each quantity. Okay, so that part we have covered in the last lecture. Now today we have to discuss about the dimensionless numbers and their physical significance. Okay, dimensionless numbers and their physical significance. So we have to discuss the different dimensionless numbers, that is what is meant by Reynolds number, then what is meant by Prandtl number, then what is meant by Nusselt number. Okay, then what is meant by Stanton number, what is meant by Piclet number, then what is meant by Grades number, and what is meant by Grashof number. Okay, so we have to cover this 7 dimensionless number one by one, and we have to understand what is the physical significance of the each dimensionless number. Okay, so write down, all of you write down the next point. Write down dimensionless numbers and their physical significance. Dimensionless numbers, dimensionless numbers and their physical significance. Dimensionless numbers and their physical significance, and their physical significance, and their physical significance. Okay, so all of you write down the first dimensionless number, that is Reynolds number. All of you write down first dimensionless number, that is Reynolds number. And what is the notation for the Reynolds number? That is Re. Already in empirical correlations we have written the formulas related to the Reynolds number, Prandtl number, Nusselt number. Now we have to discuss thoroughly what is meant by Reynolds number, what is the physical significance, what is the equation for the Reynolds number, how that equation will arise. So that part we have to cover. Okay, so all of you write down the first dimensionless number, that is Reynolds number. What is the notation for the Reynolds number? That is Re. Re is the notation for the Reynolds number. Okay, so what is the definition of the Reynolds number? Reynolds number म्हणजे काय असणार आहे, त्याची डेफिनेशन काय असणार आहे? तर इट इज डिफाइंड एज द रेशो ऑफ इनर्शिया फोर्स टू द विस्कस फोर्स. जो काही इनर्शिया फोर्स आहे, जो काही विस्कस फोर्स आहे, ह्यांचा जो काही रेशो आहे, that ratio is nothing but Reynolds number. What is meant by Reynolds number? Reynolds number is nothing but it is defined as the ratio of the inertia force to the viscous force. Okay, so all of you write down the definition of the Reynolds number. Write down the definition. Write down the definition. It is defined as, it is defined as, it is defined as the ratio of the, it is defined as the ratio of the ratio of the inertia force to the viscous force, ratio of the inertia force to the viscous force. Okay, what is meant by Reynolds number? Reynolds number is nothing but it is defined as the ratio of the inertia force to the viscous force. Inertia force to the viscous force. Okay, so in the form of equation we have to write down the Reynolds number. Write down Re is equal to, that is Reynolds number is equal to inertia force divided by viscous force. Write down Reynolds number is equal to inertia force divided by viscous force. Inertia force divided by viscous force. Inertia force divided by viscous force. Okay, then what is meant by inertia force? Inertia force is nothing but mass into acceleration. Force म्हणजे काय असते? Mass into acceleration. So instead of inertia force we have to write down inertia force is nothing but mass into acceleration. Mass into acceleration. As we know that what is the equation for the force is nothing but F is equal to m into a, that is mass into acceleration. That force is nothing but inertia force. Okay, so instead of inertia force we have to write down the mass into acceleration divided by what is the equation for the viscous force. Okay, so as we know that shear stress म्हणजे काय असते तर viscous force divided by area. So from that equation viscous force is nothing but shear stress into area. Stress म्हणजे काय असते? Stress is nothing but force divided by area. So from that equation what is meant by viscous force? Viscous force is nothing but shear stress into area. So all of you write down the equation. Instead of viscous force we have to write down the shear stress into area. Shear stress into area. Inertia force is equal to mass into acceleration, and viscous force is nothing but shear stress into area. Okay, now we have to write down this in the form of notation. So Reynolds number is equal to mass into acceleration, that is m into a, divided by shear stress into area. So as we know that Newton's law of viscosity, tau is equal to mu into du by dy. So instead of shear stress we have to write down the mu into du by dy. So du by dy is nothing but velocity divided by length. So in that form we have to write down the equation mu into v by l. Mu into v by l. Okay, and what is the area for the flat plate? That is l square. So all of you write down area is nothing but l square. समजले बघा. As we know that what is the Newton's law of the viscosity, tau is equal to mu into du by dy. mu म्हणजे काय? du म्हणजे काय असणार आहे? चेंज इन व्हेलॉसिटी, and dy म्हणजे डिस्टन्स असणार आहे. सो इन्स्टेड ऑफ शेअर स्ट्रेस वी हॅव टू राईट डाऊन दी mu into v by l. And what is the area? Area is nothing but l square. So all of you write down Re is equal to m into a divided by mu into v by l into l square. Okay, so l will be cancelled. So what is the remaining equation? Acceleration is nothing but velocity, change in velocity with respect to or velocity per unit time. Velocity per unit time. Acceleration is nothing but velocity per unit time. So therefore all of you write down the equation m into, instead of acceleration we have to write down change in velocity per unit time. So therefore v by t divided by mu into v into l, because one l will cancel. So what is the remaining equation at the denominator? That is mu into v into l. Okay, so as we know that what is the equation for the density? Density म्हणजे काय असते सांगा? Anyone, what is meant by density? Anyone, what is the equation for the density? Mass per unit volume. Density म्हणजे काय असते? Mass per unit volume. So what, from that equation what is meant by mass? Mass is nothing but density into volume. So instead of m we have to write down the density into volume. So density is nothing but rho, and v volume but v square, sorry l cube. व्हॉल्यूम काय असणार आहे प्लेटचं? एल क्यूब असणार आहे. ओके, सो राईट डाऊन instead of mass density into volume. So density is nothing but rho and volume is nothing but l cube. So rho into l cube Okay, can anyone tell me that equation is correct? Rho into L cube. Okay, so instead of time we have written the, okay, I will check the voice. Okay, sound is audible. Anyone reply me? Sound is audible. Hello. Okay. So instead of time at the denominator v by t, we have to write down the displacement per unit volume. So at the denominator there is a L and at the numerator there is a V. Okay, so all of you write down. Instead of t, we have to write down the L by V. Okay, so from that L will be cancelled. So what is the remaining equation? Rho into V square into L square divided by mu into V into L. Mu into V into L. So V into L, V into L will be cancelled. So what is the remaining equation? Reynolds number is equal to rho into V into L divided by mu. Okay, what is the equation for the Reynolds number? Reynolds number is equal to rho into V into L divided by mu. एक V into L क्या होणार आहे? Cancel होणार आहे. So what is the equation for the Reynolds number? Rho into V into L divided by mu. आता हे प्लेट असताना आपला एल आलेला आहे. समजा तिथं जर पाईप असते तर काय आलं असतं इक्वेशन? रेनॉल्ड्स नंबर इज इक्वल टू रो इंटू व्ही इंटू इन्स्टेड ऑफ एल देर इज ए डायमीटर. सो रो इंटू व्ही इंटू डी डिवाइडेड बाय म्यू. रो व्ही डी बाय म्यू असं इक्वेशन आलं असतं वेन देर इज ए pipe. Okay, and then what is the significance of the Reynolds number? Reynolds number signifies the relative predominance of the inertia to the viscous force occurring in the flow system. एखादी फ्लो सिस्टीम असेल तर त्या फ्लो सिस्टीम मध्ये कुठला फोर्स जास्त आहे? विच फोर्स इज मोर? Inertia force is more or viscous force is more? So we have to understood by using this Reynolds number. रेनॉल्ड्स नंबर वरून आपल्याला काय समजणार आहे? एखादी जी काही फ्लो सिस्टीम आहे त्या फ्लो सिस्टीम मध्ये विस्कस फोर्स जास्त आहे की इनर्शिया फोर्स जास्त आहे? सो that part we have to understood by using this Reynolds number. So this is the physical significance of that Reynolds number. Which factor is more? Which force is more? Inertia force is more or viscous force is more? So we have to understood by using this Reynolds number. Okay, so the higher value of the Reynolds number, the greater will be the relative contribution of the inertia effect. ओके, रेनॉल्ड्स नंबर जर जास्त असेल म्हणजे काय असणार आहे? रेनॉल्ड्स नंबर म्हणजे काय? इनर्शिया फोर्स टू दी विस्कस फोर्स आहे. म्हणजे इनर्शिया फोर्स जास्त असणार ऍज कम्पेअर टू दी विस्कस फोर्स. ओके, so in that way there is a physical significance of the Reynolds number. Okay, so Reynolds number is taken as a important criteria of kinematics and dynamics, similarly in forced convection heat transfer. Okay, and Reynolds number denotes the type of flow. If Reynolds number is less than 2000, then laminar flow is there, and Reynolds number is greater than 4000, then turbulent flow is there. And if Reynolds number is in between 2000 to 4000, then we have to understand that flow is transition flow. Okay, तर हा सिग्निफिकन्स आहे. म्हणजे रेनॉल्ड्स नंबर वरून आपण काय सांगू शकतोय की हा फ्लो कुठल्या टाइपचा आहे? इफ फ्लो इज लॅमिनर, then Reynolds number is less than 2000. For the turbulent flow, Reynolds number is greater than 4000, and for the transition flow, Reynolds number is in between 2000 to 4000. So this is the conclusions from the Reynolds number. म्हणजे हे सगळं आपल्याला कशामुळे समजणार आहे की फ्लो तुमचा कुठला आहे, लॅमिनर आहे की टर्बुलंट आहे? सो that part we have to understood by using this Reynolds number. So this is the physical significance of the Reynolds number. This is the physical significance of the Reynolds number. Okay, so all of you write down physical significance of the Reynolds number. Write down arrow करून लिहा. Reynolds number signifies the relative predominance of the inertia relative predominance of the inertia to the viscous force, occurring in the flow systems, inertia to the viscous force occurring in the flow systems, occurring in the flow systems, occurring in the flow systems, full stop. Next significance, next line. The higher the value of Reynolds number, the higher the value of Reynolds number, the higher the value of Reynolds number, the greater will be the higher the value of Reynolds number, the greater will be the relative contribution of the inertia effect, greater will be the relative contribution of inertia effect, relative contribution of inertia effect, relative contribution of inertia effect, full stop. The smaller the value of Re, the smaller the value of Reynolds number, the smaller the value of Reynolds number, the greater will be the relative magnitude of the greater will be the relative magnitude of the viscous stresses, relative magnitude of the viscous stresses, viscous stresses, viscous stresses. समजलं का बघा, रेनॉल्ड्स नंबर जास्त असणार आहे. रेनॉल्ड्स नंबर म्हणजे इनर्शिया फोर्स डिवायडेड बाय विस्कस फोर्स. रेनॉल्ड्स नंबर जास्त आहे म्हणजे इनर्शिया फोर्स जास्त असणार आहे, आणि रेनॉल्ड्स नंबर कमी आहे म्हणजे कुठला फोर्स जास्त असणार, विस्कस फोर्स जास्त असणार. दॅट पार्ट वी हॅव टू अंडरस्टूड बाय युजिंग दिस रेनॉल्ड्स नंबर. ओके, दिस इज द सिग्निफिकन्स. देन राइट डाउन द नेक्स्ट लाइन. Reynolds number is taken as important criteria. Reynolds number is taken as Reynolds number is taken as an important criteria of kinematic and dynamic similarities, important criteria of kinematic and dynamic similarities in forced convection heat transfer, important criteria of kinematic and dynamic similarities in forced convection heat transfer, in forced convection heat transfer. Okay, then next line, write down the significance. Reynolds number denotes the type of flow. Reynolds number denotes the type of flow. Reynolds number denotes the type of flow that is Re is less than 2000, Re is less than 2000, then flow is laminar. Re is less than 2000, laminar flow is there. Re is greater than 4000, turbulent flow is there. Re is greater than 4000, turbulent flow is there. And Re is in between 2000 to 4000, then transition flow is there. Okay, so this is understood by using this Reynolds number. हे आपल्याला कशावरून समजलं की ज्यावेळेला रेनॉल्ड्स नंबर 2000 पेक्षा कमी असणार आहे त्यावेळेला आपल्याला काय समजणार आहे की हा फ्लो जो आहे तो लॅमिनर असणार आहे. सो दिस इज द फिजिकल सिग्निफिकन्स ऑफ द रेनॉल्ड्स नंबर. सो ऑल ऑफ यू राइट डाउन. Reynolds number is less than 2000, laminar flow. Reynolds number greater than 4000, turbulent flow. And Reynolds number in between 2000 to 4000, there is a transition flow. Okay, so this is the first dimensionless number, that is Reynolds number. What is the equation for that? Rho VL by mu. Okay, then write down the second dimensionless number. Write down Prandtl number. Write down second dimensionless number, that is Prandtl number, and it is denoted by PR. Prandtl number, it is denoted by PR. Prandtl number, that is PR. And write down the definition of the Prandtl number. It is the ratio of kinematic viscosity to the thermal diffusivity. All of you write down the definition of Prandtl number. It is the ratio of kinematic viscosity to It is the ratio of kinematic viscosity to thermal diffusivity So write down in the form of equation Prandtl number is equal to kinematic viscosity divided by thermal diffusivity. Kinematic viscosity divided by thermal diffusivity. समजलंय बघा Prandtl number काय असणार आहे? It is the ratio of kinematic viscosity to the thermal diffusivity. Kinematic viscosity कशाने डिनोट केली जाते? तर न्यू न. न्यू divided by thermal diffusivity is denoted by alpha. So nu by alpha is nothing but Prandtl number. Okay. Write down the again one definition of the Prandtl number. It is also defined as, write down another definition for the Prandtl number. It is also defined as ratio of molecular diffusivity of momentum. It is also defined as ratio of molecular diffusivity of momentum to the molecular diffusivity of heat. Molecular diffusivity of heat. Write down that equation. Prandtl number is equal to molecular diffusivity of momentum divided by molecular diffusion of heat. Molecular diffusion of heat. Okay. So what is the equation for the molecular diffusivity of momentum? That is mu into Cp. And what is the equation for the molecular diffusion of heat? That is K. That is thermal conductivity. Write down Prandtl number is equal to mu Cp by K. Prandtl number is equal to mu Cp by K. Then again divide and multiply by rho. So therefore we get the equation as a Prandtl number is equal to mu Cp by K. Then multiply and divide by rho. So therefore mu by rho into rho Cp by K. So from that equation we have to rearrange the term. So Prandtl number is equal to mu by rho is equal to K by rho Cp. We are rearranging the term, and as we know that mu by rho is nothing but nu and K by rho Cp means alpha. That is nothing but Prandtl number, kinematic viscosity divided by thermal diffusivity. Okay. Then write down the significance of the Prandtl number. Write down case 1, Prandtl number is less than 1. समजले. जे काही आपण डायमेन्शनलेस नंबर बघणार आहे त्याचं जे काही इक्वेशन आहे त्या इक्वेशन वरून तुम्ही त्याचा फिजिकल सिग्निफिकन्स लिहू शकताय. आता रेनॉल्ड्स नंबर मध्ये आपण काय लिहिलं? इट इज द रेशो ऑफ इनर्शिया फोर्स टू द विस्कस फोर्स. म्हणजे रेनॉल्ड्स नंबर जर जास्त असेल तर इनर्शिया फोर्स तर जास्त असणार आहे हे आपल्याला समजणार आहे. रेनॉल्ड्स नंबर कमी असेल तर विस्कस फोर्स जास्त असणार आहे हे आपल्याला समजणार आहे. सो दिस इज द फिजिकल सिग्निफिकन्स. So from that Reynolds number we have to understood in that flow system which force is more. Okay, so in that manner we have to write down the significance of the each dimensionless number. Now we have to write down the case number 1. If Prandtl number is less than 1, write down if Prandtl number is less than 1, then draw this diagram. Fluid having velocity is u meter per second, then velocity boundary layer and thermal boundary layer is there. Prandtl number 1 पेक्षा कमी आहे त्यावेळेला काय असते तर थर्मल बाउंड्री लेअर चा थिकनेस जो आहे तो जास्त असणार आहे. तर डोटी काय जास्त आहे ऍज कम्पेअर टू डो म्हणजे काय असणार आहे तर तो व्हेलॉसिटी बाउंड्री लेअर थिकनेसचा थिकनेस असणार आहे आणि डोटी हा थर्मल बाउंड्री लेअरचा थिकनेस असणार आहे. इफ Prandtl number is less than 1 at that time, thermal boundary layer thickness is greater than velocity boundary layer. Okay, so all of you draw this diagram. Okay, draw this diagram. VBL, TBL, dou T, cold fluid velocity is u meter per second. Okay, then write down the statement. Prandtl number is less than 1 means here heat diffuses slowly than diffusion of momentum. Here heat diffuses slowly than diffusion of momentum. Write down the example liquid metal. Liquid metal. Okay. Then consider the case number 2. Prandtl number is equal to 1. So VBL is equal to TBL. Whatever the thickness of VBL, that same thickness for the TBL. So draw that diagram. TBL and VBL at the same location and dou is equal to dou T. So from that write down here both diffusion of heat and momentum is same. हीटचं जे काय डिफ्युजन असणार आहे आणि मोमेंटमचं जे काय डिफ्युजन असणार आहे ते काय असणार आहे सेम असणार आहे. एक्झाम्पल काय तर गॅसेस. ओके. सो राईट डाऊन हिअर बोथ द डिफ्युजन ऑफ हीट अँड मोमेंटम इज सेम. हिअर हिअर बोथ diffusion of heat here both diffusion of heat and momentum is the same as is the same. Example gases. Okay, then write down the case number 3. Case number 3, Prandtl number is greater than 1. Case number 3, Prandtl number is greater than 1. So in this case thickness of velocity boundary layer is greater than thermal boundary layer. So draw this diagram. Case number 3, Prandtl number is greater than 1. TBL, VBL. TBL having this thickness is dou T. VBL having thickness is dou. So for such cases heat diffuses quickly. For such cases for such cases for such cases heat diffuses quickly. Example is oils. So these are the physical significance. Case 1, case 2, case 3. म्हणजे प्रँटल नंबर लेस दॅन 1 असताना काय होणार, प्रँटल नंबर इक्वल टू 1 असताना काय असणार आहे आणि प्रँटल नंबर ग्रेटर दॅन 1 असताना काय असणार आहे. तर हे कशावरून आपल्याला समजणार आहे, तर ते डायग्राम वरून आपल्याला समजते आणि त्या इक्वेशन वरून आपण प्रँटल नंबर ग्रेटर दॅन 1 असेल तर काय म्हणू शकतोय, हीट डिफ्युजेस क्विकली. Okay, so these are the significance of the Prandtl number. Then write down the third number, that is Nusselt number. Write down Nusselt number. Write down Nusselt number. Write down the definition of Nusselt number. It is defined as the ratio of the. It is defined as the ratio of the. It is defined as the ratio of the heat flow rate by convection. It is defined as the ratio of the heat flow rate by convection to the heat flow rate by conduction. Okay. हीट फ्लो जो काही कन्व्हेक्शन होणार आहे आणि हीट फ्लो जो काही कंडक्शन होणार आहे, that ratio is nothing but Nusselt number. Write down, it is defined as the ratio of the heat flow rate by convection to the heat flow rate by conduction. Heat flow rate by conduction. So now draw one diagram. There are two layers having velocities u meter per second. One layer having temperature is T1, another layer having temperature is T2. Okay, and difference between these two layers is L, and heat transfer takes place from one layer to the another layer, that is Q. Okay, so all of you draw this diagram. Two layers are there having velocities u meter per second, having temperatures are T1 and T2. Distance between two layers is L. Okay, and T1 is greater than T2, so therefore heat transfer from bottom layer to the upper layer is takes place. Okay, and delta T is nothing but T1 minus T2. ओके, ज्यावेळेला हे दोन्ही लेअर मोशन मध्ये असणार आहे त्यावेळेला हीट ट्रान्सफर कशामुळे होणार आहे, बिकॉज ऑफ दी कन्व्हेक्शन. अँड व्हेन दिस टू लेयर्स आर स्टेशनरी, हीट ट्रान्सफर बाय दी कंडक्शन. So for these two conditions we have to write down the equation, and that two equation ratio is nothing but Nusselt number. Okay, so all of you write down, when these two layer in motion, 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 therefore heat transfer by convection, therefore heat transfer by convection, q convection is equal to h into a into delta t, h into a into delta t. Heat transfer by convection, q convection is equal to h into a into delta t. Okay. Then when these two layers are stationary, when these two layers are stationary, when these two layers are stationary, therefore heat transfer by conduction, when these two layers are stationary, therefore heat transfer by conduction. So what is the equation for the Q conduction? K into A into dt by dx. So in that manner we have to write down the equation for this diagram, that is Q conduction is equal to K into A into dt by L. Write down Q conduction is equal to K into A into dt by L. So therefore Nusselt number is, what is the, as per the definition, what is meant by Nusselt number? Q convection divided by Q conduction. Rate of heat transfer by convection divided by rate of heat transfer by the conduction. So Q convection divided by Q conduction is equal to, what is the equation for the Q convection? That is H into A into delta T. And what is the equation for the Q conduction? K into A into delta T divided by L. So A and delta T will be cancelled. So what is the remaining equation? HL by K. So this is the equation for the Nusselt number, that is HL by K. HL by K. HL by K. So this is the equation of the Nusselt number, HL by K. Then write down the significance. Significance of the Nusselt number. Case 1, Nusselt number is equal to 1. Nusselt number is equal to 1. Nusselt number ज्या वेळेला 1 असणार आहे त्यावेळेला काय म्हणू शकतो आपण? The heat transfer is only by conduction and there is a no heat transfer by convection. ओके, कारण Q convection आणि Q conduction जर सेम झालं तर आपण heat transfer conduction मुळे होते असं म्हणू शकतो. ओके, so all of you write down significance. Case 1, Nusselt number is equal to 1. Nusselt number is equal to 1. The heat transfer is only by, the heat transfer is only by conduction. The heat transfer is only by conduction. The heat transfer is only by conduction and there is no heat transfer by convection, and there is no heat transfer by convection. So therefore we have to write down Q conduction is equal to Q convection. Therefore we have to write down Q conduction is equal to Q convection. Q conduction is equal to Q convection. Then write down case number 2. Case 2, when Nusselt number is greater than 1. Case 2, when Nusselt number is greater than 1. Case 2, when Nusselt number is greater than 1. So Nusselt number is greater than 1 means what? Q convection is greater than Q conduction. So therefore the heat transfer is mainly by convection. So all of you write down when Nusselt number is greater than 1. When Nusselt number is greater than, when Q convection is greater than Q conduction. Q convection is greater than Q conduction. The heat transfer is mainly by convection. Then write down case number 3, when Nusselt number is less than 1. When Nusselt number is less than 1. This is the fundamental error. This condition is not possible. Okay. So whatever the flow system is there, in that case, Nusselt number is less than 1. That condition is not possible. So therefore, this is a fundamental error. This is a fundamental error. This is a fundamental error. Okay. Then write down the fourth dimensionless number, Stanton number. Write down first. We have to complete these 7 numbers. Write down Stanton number. Notation is ST. Stanton number notation is ST. Write down the definition. It is defined as Stanton number. It is denoted by ST and it is defined as the ratio of, it is defined as the ratio of the convective heat flux to the, it is defined as the ratio of the convective heat flux to the heat transfer capacity of fluid. It is defined as the ratio of the convective heat flux to the convective heat flux to the heat transfer capacity of a fluid. Heat transfer capacity of a fluid. heat transfer capacity of a fluid. So therefore write down ST, that is Stanton number, is equal to convective heat flux divided by heat transfer capacity of fluid. Stanton number is equal to convective heat flux divided by heat transfer capacity of a fluid. Heat transfer capacity of fluid. Okay. So convective heat flux, what is the equation for the convective heat flux? That is H into delta T, because our equation is H into A into delta T, but this is the heat flux. So heat flux is nothing but rate of heat transfer per unit area. So area will be cancelled. So therefore Stanton number is equal to convective heat flux is denoted by H into delta T, and heat transfer capacity of fluid is nothing but mCp delta T, that is m dot Cp delta T. Okay, so delta T delta will cancel. So what is the remaining equation? H divided by mass into specific heat. And how to write the mass? Density into volume. So rho into V into Cp. Rho into V into Cp. Okay. Then Stanton number is equal to आपण काय केलेलं आहे बघा, नेक्स्ट इक्वेशन मध्ये एल न मल्टिप्लाय आणि डिवाइड केलेलं आहे, त्याच्यानंतर म्यू न मल्टिप्लाय आणि डिवाइड केलेलं आहे, अँड के न मल्टिप्लाय आणि डिवाइड केलेलं आहे. सो फ्रॉम दॅट we have written the equation in the form of Stanton number is equal to HL by K divided by rho VL by mu into mu Cp by K. जर तुम्ही टर्म कॅन्सल केलं तर तुम्हाला तेच इक्वेशन मिळणार, H by rho into V into Cp. So for the we get the relation between the another dimensionless number, we have written the equation in this form. Stanton number is equal to HL by K divided by rho VL by mu into mu Cp by K. So from that HL by K is म्हणजे Nusselt number, rho VL by mu म्हणजे Reynolds number, mu Cp by K म्हणजे Prandtl number. Okay. And what is the significance? That is Stanton number can be used only in correlating forced convection data. फोर्स्ड कन्व्हेक्शन जो काय डाटा आहे तो कोरिलेट करण्यासाठी आपण काय यूज करू शकतोय? स्टॅन्टन नंबर यूज करू शकतोय. दिस इज द फिजिकल सिग्निफिकन्स. सो राइट डाउन स्टॅन्टन नंबर कॅन बी युज्ड, स्टॅन्टन नंबर कॅन बी युज्ड ओनली इन, स्टॅन्टन नंबर can be used only in correlating forced convection data. Correlating forced convection data. Okay. So this is the fourth number, that is Stanton number. Then write down the fifth dimensionless number, that is Piclet number. Write down the next dimensionless number, that is Piclet number. Write down the definition of the Piclet number. It can be expressed as Piclet number. It can be Piclet number. It can be expressed as, it can be expressed as, it can be expressed as the product of Reynolds number and Prandtl number. Piclet number काय असणार आहे तर Reynolds number आणि Prandtl number चा product असणार. It can be expressed as a product of Reynolds number and Prandtl number. So therefore write down Piclet number is denoted by P. So P is equal to Reynolds number into Prandtl number. P, that is Piclet number, is equal to Reynolds number into Prandtl number. Reynolds number into Prandtl number. Reynolds number into Prandtl number. Then write down the equation of the Reynolds number, rho VL by mu. Equation of the Prandtl number, mu Cp by K. So in that form we have to write down the Piclet number. Piclet number is equal to rho VL by mu into Prandtl number is nothing but mu Cp by K. Okay, so mu will be cancelled. So what is the remaining equation? Rho VL Cp divided by K. And then multiply and divide by this equation by delta T. So therefore equation becomes Piclet number is equal to rho V L Cp delta T divided by K into delta T. Okay. Then we have to written this same equation as a Piclet number is equal to rho V into Cp into delta T divided by K into delta T divided by L. ओके. सो रो व्ही सीपी डेल्टा टी म्हणजेच काय असणार आहे? एम सीपी डेल्टा टी. आणि हा काय आहे बघा, डिनॉमिनेटर के इंटू डेल्टा टी बाय एल. म्हणजे हा कंडक्शन आहे आणि न्यूमरेटर जो आहे तो कन्व्हेक्शन आहे. Okay, so therefore all of you write down, therefore it is the ratio of Piclet number म्हणजे काय असणार आहे? What is the definition of the Piclet number? It is the ratio of mass heat flow rate mass heat flow rate by convection mass heat flow rate by convection to the heat flow rate by conduction to the heat flow rate by conduction under a unit temperature gradient under a unit temperature gradient and through a thickness L and through a thickness L okay, so this is the definition of the Piclet number. What is the definition of the Piclet number? It is the ratio of mass heat flow rate by convection to the heat flow rate by conduction under a unit temperature gradient through a thickness L. Okay, then write down the sixth dimensionless number, that is Grade's number. Write down, it is denoted by capital G. Write down Grade's number. It is denoted by capital G. Write down the definition of the Grade's number. It is defined as the ratio of the heat capacity of fluid. It is defined as the ratio of the heat capacity of fluid flowing through the pipe. It is defined as the ratio of the heat capacity of fluid flowing through the pipe. Per unit length of the pipe to the conductivity of the pipe. Okay, what is meant by Grade's number? It is defined as the ratio of heat capacity of fluid flowing through the pipe per unit length of the pipe to the conductivity of the pipe. Okay, heat capacity म्हणजे काय असणार आहे? m dot into cp per unit length म्हणजे divided by L. So write down G is equal to m dot cp divided by L divided by K. So m dot cp divided by L K. Mass flow rate म्हणजेच काय असते? Density into discharge. Mass flow rate is nothing but density into discharge. So instead of m dot we have to write down rho into Q. So rho into Q into cp divided by L into K. Rho into Q into cp divided by L into K. And discharge is nothing but area into velocity. So instead of Q we have to write down area into velocity, that is A into V. So therefore rho into A into V into cp divided by LK. Okay, and as we know that thermal diffusivity, that is alpha, is nothing but K divided by rho into Cp. So K divided by rho into Cp. Instead of that we have to write down the alpha. So therefore equation becomes G is equal to A into V divided by L into alpha. Alpha म्हणजे काय असते? K divided by rho into Cp. So therefore equation becomes G is equal to A into V divided by L into alpha. Okay, so area is nothing but pi by 4 d square into V divided by L into alpha. So Vd upon alpha is equal to pi d divided by 4 into L. Okay. So Gates number is equal to, what is the equation of the Piclet number? So by the simplification we get the Gates number as a G is equal to Piclet number into bracket pi into d divided by 4. Okay, so Gates number is merely a product of Piclet number and a constant. Okay, so all of you write down Grade's number is merely a product of Piclet number and a constant. Product of Piclet number and a constant. Product of Piclet number and constant. Product of Piclet number and constant. Okay, and write down the last dimensionless number, that is Grashof number. It is denoted by GR. Grashof number, it is denoted by GR. And write down the definition of the Grashof number. So Grashof number is related to the natural convection heat transfer. So all of you write down Grashof number is related with Grashof number is related with Grashof number is related with natural convection heat transfer. Grashof number is related with natural convection heat transfer. Natural convection heat transfer. Natural convection heat transfer. Grashof number is related with natural convection heat transfer. Write down the definition. It is defined as the ratio of the product of inertia force. It is defined as ratio of the product of inertia force and buoyancy force. Product of inertia force and buoyancy force to the square of viscous force. It is defined as ratio of product of inertia force and buoyancy force to the square of viscous force. To the square of viscous force. Square of viscous force. So write down in the form of equation, Grashof number is equal to inertia force into buoyancy force divided by viscous force square. Inertia force into buoyancy force divided by viscous force square. Viscous force square. Okay, write down the equation. Already we have derived the equation for the inertia force, that is rho into v square into L square. What is the equation for the buoyancy force? That is rho into beta into g into delta T L cube. And viscous force, that is mu into v into L bracket square. Mu into v into L bracket square. So by the simplification of this equation, we get the Grashof number as a g beta delta T L cube divided by nu square. G beta delta T L cube divided by nu square. So all of you write down the, by the simplification, we get the Grashof number as a beta g delta T L cube divided by nu square. Divided by nu square. Divided by nu square. So write down one statement. Free convection is usually suppressed at sufficiently small Grashof number. Sufficiently small Grashof number, comma, begins at some critical value of Grashof number. Begins at some critical value of Grashof number. Begins at some critical value of Grashof number, depending upon the arrangement. Depending upon the arrangement. And then becomes more and more effective with increasing Grashof number. And then becomes more and more effective with increasing Grashof number. With increasing Grashof number. Okay, all of you complete that statement. Okay, so all of you put your roll numbers in the chat box. Thank you very much. Remaining part we have to see in the tomorrow's lecture. Okay, so at 3 p.m. there is a ISC. Okay, so all of you prepare for the ISC. Best luck for the ISC. Okay, sir, stop the recording and leave the meeting.